Welcome back to the OpenVINO channel. Here is a great way to benchmark models on multiple devices, multiple parameters, calibrate to int8, compare and analyze the results, and even get a package ready to deploy the inference without writing a single line of code. In this video, video 42, I'll show you the basic operations end-to-end. In the next video, video 43, I'll show you how to compare multiple runs, multiple parameters, calibrate to integer, and more. The deep learning workbench is well documented. You can follow this link to get all the details. There are even recorded video instructions, but let me give you my quick overview. These are the high-level steps. I'll demonstrate them one by one. We will install and start using the workbench. We'll get a model, prepare it for inference, get our dataset and benchmark the model. Then we have many options to analyze the results and maybe rerun the benchmark with other parameters. Then we take the preferred configuration and download a package that could be used on an edge device for deployment. Let's start. There are many options to get the DL workbench. You can install it with the OpenVINO package and in the future even on the dev cloud. The easiest way is probably to get it from Docker Hub and run it in a container. Let's check if I already have an image. Yes, I have the OpenVINO latest. Let's see if I have a container. No containers. But it all does not matter when you run this command, and you can find it in the video description. Just copy and paste. Run it with sudo permissions. If you already have an image, it will create a new container. If not, it will download the image for you. Give it a new name. The tag is a workbench latest. And if you have an integrated GPU or myriad device like NCS, please enable them using these flags. And it's running, and all you have to do is to open the link, and you have the workbench open in your browser. First thing is to get a deep learning based model. You can bring your own model or get it from the OpenVINO Open Models. Let's open the link in a web browser, create a new configuration, and import a model. I can load my original model. You can see the format accepted. For example, TensorFlow version 2, choose a file, and so on. But I will just download a model. I'll choose an SSD MobileNet model, and let's get it. Then, sometimes the model needs some preparation. So the model optimizer is built into the DL workbench. int8 calibration is possible in a later stage and only if you supply a dataset. So I'll demonstrate it only in the next video, video 43. If your model is already in an IR format or in an ONNX format, it needs no conversions. But our model does need it, as it is now still in CAFE format. So I'll choose FPX16 and convert it. Please note that until the model is ready, we cannot choose a target device, as not all models are supported by all devices. Once the model is converted, I can choose the target device. I have on this system a CPU, an integrated GPU, and an NCS2 VPU stick. I will choose the CPU. Now we need a dataset. You can bring your own dataset in multiple formats or generate a synthetic one. For this example, I will not use a dataset and I will just generate one. The tool already knows the expected image sizes, and I will generate 100 synthetic noise images. It does limit me because I will not be able to calibrate to integer and other operations, but sometimes this is good enough. And now we are ready to benchmark the model. So we have the model, we have the target device, CPU in this case, and we got the dataset, synthetic in our case. Now we can create the first benchmark point. And we are getting 1 point on the graph, latency of almost 10 milliseconds and throughput of 101 frame per second. Let's create another point. I'll try batch 8 and execute. As you can see, I can choose batch size and number of parallel streams for execution. And we have a graph. Now, I can choose my preferred performance point and trade-off latency with throughput in this case. Next stage is to analyze the results. We have few tools that will give you insights on the performance of your neural network. We can choose one of the performance points, explore the execution time by layers, and we can visualize the model. Here is how the IR graph looks like. And here is how the N graph, the actual execution graph, looks like. We can either color code it to easily detect which layers took more time to execute. And I have here a table of all the layers. Let's sort it by execution time. Layer conv3 took most of the execution time. It was executed 6th and took about 6 milliseconds. You can see here all the information on this layer, how it was fused from several IR operations into a single execution convolution. And in the next video, I'll talk about more optimization techniques like calibrating to integer and others. So we can analyze the results, tune the benchmark parameters, and rerun the higher batch or different number of streams until we're happy with the results. Once the inference performance meets our requirements, we would like to take the model with the exact parameters into our target device for inference. So we can go to Pack, specify the target device. Here it's only CPU. Do you want the model included? And so on. And the deployment package is generated for us. It is expected to be 55 meg, and the only limitation is that it only supported on Ubuntu 18. Deploying the inference on your target machine requires few more steps. You can find them in this link. So we have seen a great way to benchmark models from installation to deployment using a web application. The demo that I showed you would have taken me a lot more time if I had to operate all these scripts and options by myself. Next video, video 43, I'll show you a much more complex example on multiple devices with integer calibration and more. See you there.